Every device in an IP network requires a valid IP configuration. There are two ways to configure IP configuration on a device: manual and dynamic. In the manual method, we manually assign IP configuration to devices. In the dynamic method, we configure the DHCP service. The DHCP service automatically provides IP configuration to devices. If your network size is small, you can use the manual method to configure and manage IP addresses on all devices. But, if your network size is big, the manual method will not work for you. Let's understand it through an example. Suppose you are a network administrator in a company that has more than 2,000 devices in its network. The company bought a new internet connection and asked you to configure all devices to use the new internet connection. Depending on how you previously configured the IP configuration on all devices, this could be an easy or difficult task for you. If you manually configured the IP addresses on all devices, you need to configure all devices again. However, if you use DHCP, then you only need to change the configuration on the DHCP server. When the clients reboot or renew their IP configuration, they will automatically acquire the new IP configuration from the DHCP server. To provide an IP configuration, a DHCP server can use three methods. These methods are static, dynamic, and automatic. In the static allocation method, the administrator configures an allocation table on the DHCP server. In this table, the administrator adds the MAC addresses of all clients and assigns an IP configuration to each client. The DHCP server uses this table to provide IP configurations. When a client requests an IP configuration, the DHCP server finds the client's MAC address in the table. If it finds an entry for the client, it provides the IP configuration to the client. In the dynamic allocation method, the administrator configures a range of IP addresses on the DHCP server. The DHCP server assigns an IP configuration from the configured range to each client that requests an IP configuration. In this method, DHCP offers the IP configuration only for a specific time, known as the lease. The IP configuration remains valid until the lease duration is over. Once the lease duration is over, the client is required to obtain a new IP configuration from the server again. The automatic allocation method is similar to the dynamic method. In this method, the administrator configures a range of IP addresses on the DHCP server, and the DHCP server assigns an IP configuration from the configured range to each client that requests an IP configuration. But in this method, the DHCP server assigns the IP configuration permanently. For this, the DHCP server sets the lease duration to infinite. As a result, once the DHCP server chooses an IP configuration from the pool and assigns the IP configuration to a client, the IP configuration remains with that same client indefinitely. When a DHCP client needs an IP configuration, it connects to a DHCP server and requests an IP configuration. A DHCP server contains several pre-configured IP configurations. When it receives a DHCP request from a DHCP client, it provides an IP configuration to the client from all available IP configurations. This process goes through 4 steps: discover, offer, request, and acknowledgement. Let us understand these steps through an example. Suppose a network has 3 PCs and 2 DHCP servers. Currently, PCs have no IP configurations. DHCP service is configured on both servers. Now, let's understand how a PC in this network will get its IP configurations from the DHCP server. When we start a device, it checks whether a valid IP configuration is available. If it is not available, the device generates a special message known as the DHCP discover message and broadcasts this message on the local LAN segment. In this message, the device uses the addresses 0.0.0.0 and 255.255.255.255 in the source and destination address fields. Any device, whether it has a valid IP configuration or not, can use these addresses to send and receive messages in the local network. From these addresses, 0.0.0.0 is used as the source address. If a device does not have the source address, it can use this address to send broadcast messages. 255.255.255.255 is the local broadcast address. Any message sent to this address is received by all hosts on the local network. Since the client sends the DHCP discover message to the local broadcast address, if a DHCP server is configured on the local network, it also receives the message. If multiple DHCP servers are configured on the local network, they all receive the DHCP discover message. A DHCP discover message includes the client's MAC address. DHCP servers use it to assign and track the IP configuration. If multiple DHCP servers are available, based on their configuration, one of them or all of them can reply to the DHCP discover message. In reply to the DHCP discover message, a DHCP server sends a DHCP offer message to the client. Since the client does not have an IP address, the DHCP server cannot send the DHCP offer message directly to the client. It sets the destination address to 255.255.255.255. In other words, a DHCP server also broadcasts the DHCP offer message to the local network. The DHCP offer message contains an IP configuration and protocol-specific information such as the lease duration and the client's MAC address in the client ID field. An IP configuration typically includes an IP address for the client, the subnet mask of the proposed IP address, the default gateway's IP address, and the DNS server's IP address. All hosts on the local network receive the DHCP offer message. They check the client ID field of the message. If a host sees its MAC address in the client ID field, it knows the message is intended for it. If a host sees the MAC address of another host in the client ID field, it knows the message is not intended for it. The host that sent the DHCP discover message accepts the DHCP offer message. Apart from the original host, all other hosts ignore the message. Depending on the number of DHCP servers, a host may receive multiple DHCP offer messages. If a host receives multiple DHCP offer messages, it accepts only one message and tells the corresponding server with a DHCP request message that it wants to use the offered IP configuration. DHCP servers generate and use a unique transaction ID for each DHCP offer message. The client includes this ID in the DHCP request message. Just like hosts use the client ID field of the DHCP offer message to know whether the message is intended for them or not, DHCP servers use the transaction ID field of the DHCP request message to know whether their offer has been accepted or not. If a DHCP server sees its transaction ID in the DHCP request message, it knows its offer has been accepted. If it sees a transaction ID of another server, it knows its offer has been rejected. Besides the server whose offer has been accepted, all other servers withdraw their offer and return them to the pool of available addresses. Let's understand this process through this example. Suppose, server 1 offers the IP address 10.0.0.1. It uses TX1 in the transaction ID field. Server 2 offers the IP address 192.168.0.1. It uses TX2 in the transaction ID field. The client accepts server 1's offer, and reply with a DHCP request message. It includes TX1 in the DHCP request message. When this message reaches both servers, both check the transaction ID and MAC address fields to know whether their offer has been accepted. Server 1 sees its transaction ID and knows its offer has been accepted. It adds the offered IP to the assigned or leased IP addresses list. Server 2 sees another server's transaction ID and knows its offer has been rejected. It adds the offered IP back to the available addresses list. When the DHCP server receives a DHCP request message from the client, the configuration process enters its final stage. In this stage, the server sends a DHCP ACK message to the client. The DHCP ACK message is an acknowledgment to the client indicating that the DHCP server has received the DHCP request message of the client, and the client can use the offered IP configuration. This way, the process of obtaining an IP configuration from a DHCP server goes through 4 stages: discover, offer, request, and acknowledgement. In the first stage, the client broadcasts a DHCP discovery message to find a DHCP server. In the second stage, the server broadcasts a DHCP offer message that includes an IP configuration, lease duration, and the client's MAC address in response to the DHCP discovery message. In the third stage, the client accepts the offered IP configuration and sends a DHCP request message to inform the DHCP server about it. In the fourth stage, the DHCP server sends an acknowledgement for the client's DHCP request message. That's all for this video. If you have any suggestions, comments, or feedback about this video, please share them in the comment section given below.